In this video, I would like to talk about numerical integrations. Okay. Now consider sometime if you have a hard time to find the antiderivative of f, or sometime the integrand is not a function, then how do we actually finding the definite integral then? Okay. So back to chapter 1, we have learned some of the technique already. Is we are going to work with the left endpoint approximation, the right endpoint approximation, or the midpoint approximations. Okay. However, you will see that, for example, to this function f right here, if we work with the left endpoint, okay, then you will see that, wow, actually we have a lot of error right here, right? You see, those are the error. Of course, we know that if we want to reduce the error, then we could make n getting closer and closer to infinity, okay? However, what if I actually, is there another way to actually to have a better approximations then? Consider that, how about if we average the L sub n and the L sub n? Probably we may be able to reduce some of the error already, okay? In fact, we have a technique to do this. We call this trapezoidal approximation then. Okay, now before I introduce the trapezoidal approximations, I would like to talk about the notation that we are using. You see, we have y naught, y sub 1, y sub 2, okay? What are they? Now, if you look at the graph, what is y naught? Basically, y naught is when the input is x naught. So y naught basically is f of x naught, okay? And then you will see that y sub n is what? F of x sub n then. Okay. This is the input right here. Okay. That's it, okay? Okay, so let us look at the kind of like the formula, okay, for the trapezoidal approximations. If we integrate between a and b of f of x dx, approximately equals to t sub n, the trapezoidal approximations, is equal to delta x over 2. What is delta x? Delta x basically is b minus a over n multiplied to y naught plus 2 times y sub 1 plus 2 times y sub 2 up to 2 times y sub n minus 1 plus the last term is y sub n. Okay, so you will see that the pattern base, the coefficient, okay, is 1 and then 2, 2, 2, 2, 2, 2, 2, and then the last one is 1. Okay. Okay, then now let's try to do the following example now. Now, to this example, I would like to find t sub 5, okay? And of course, the interval that we are working with is between x equal to 0 to x equal to 5. And because it's t sub 5, right? So basically, n is equal to 5 then, okay? And now you see y naught basically is f of 0. So this is my y naught is equal to 3. And y sub 1 is f of 1, right? F of 1 is 3.5, okay? And y sub 2 is 4. Y sub 3 is 1.5. Y sub 4 is 1. And then y sub 5 is 0.5. And now my delta x is b5 minus a 0 over n. So my delta x is equal to 1. Okay, then now we could calculate t sub 5 now. So it will be 1/2 times delta x, 1, multiplied to y naught 3 plus 2 times y sub 1, 2 times y sub 2, 2 times y sub 3, times y sub 4 plus, remember, just y sub 5, right? And then if you use a calculator, we find out that the sum is 23.5 divided by 2 is give us 11.75. So meaning in this case, the area is approximately equal to 11.75. Okay, and then let's check out the error. Okay, compared to, again, if we work with the left endpoint, okay, you will see that we have those error right here, right? Okay, then how about trapezoidal approximations? And then we work with this, and you see here, here, of course, you will see that we still have some error, but you will see that those error is reduced by a lot already. Okay, this is the idea about the trapezoidal approximations. The next one, I would like to talk about the Simpson rule. Okay, now the Simpson rule basically is the weight average between trapezoidal and the midpoint approximations. And then after we calculate the idea, we are going to, we find out that this is how we define it, okay? Is S of n is 1/3 t times n over 2 plus 2 over 3 m sub n over 2, okay? Now, this is if you want to see the detail how we come up with the Simpson rule, then you could look it back to the textbook, okay? Or search the internet, right? And now, the Simpson rule is S of n equal to 1/3 times delta x, and then multiply to y naught plus 4 times y sub 1 plus 2 times y sub 2, and then the next one would be 4 times y sub 3 plus 2 times y sub 4, okay, and then plus 4 times y sub n minus 3 plus 2 times y n minus 2 plus 4 times y n minus 1 plus y sub n, okay, and then you will see that the pattern is 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, and then 1. Now remember, it must be 4, then 1, or 1 and 4, okay? It must be this way. So that's why, in order to work with the Simpson rule, n must be even. Okay? If n is odd, then we cannot do this. For example, like the last example, if we have n equal to 5, we could not do this. N must be even. Okay. And remember, I mentioned the error band, right? So what is error band? We are using the L sub n, R sub n, M sub n, T sub n, or even S sub n, okay, to approximate the area under the functions. We call the difference in between the actual values and the approximation the error. Okay. So therefore, again, basically, if we want to integrate between a to b, from a to b of f of x dx is equal to the approximations plus the error. Is become the total area. And here is how we find the error band for the trapezoidal approximations and the midpoint approximations. Okay, now these two. This one right here is for the trapezoidal, and this one right here is for the midpoint. Okay, and of course we also have the error band for the Simpson rule as well. This is the one. Now you will see that in order to find the error band, we are going to work with the k values. what is K? K is actually is greater than or equal to the absolute value of f double prime of x. So therefore, what does this mean by K? Basically, K is the maximum values of the f double prime of x. Okay, for x is between a and b. Okay, so after we find K, then we will be able to find the error band for trapezoidal rule and also the midpoint rules. Okay, and of course, when we try to find the error band for the Simpson rule, the K is a little bit different. Okay, because the K for the Simpson rule is the fourth derivative of the function f. Okay, and then we are looking for the maximum values of it. Okay, we are going. We will have some example to work it out. That's mean to find the error band. So okay, so if you have a question, remember, ask me, right? So here is the rule that k can be k can be any numbers larger than all the values of f double prime of x, but smaller values of k given better error bands then. Okay, so right now let us work with our first example. Okay, to this one right here, we would like to find t sub n trapezoidal approximation, the midpoint approximation, and the Simpson. Okay. Let's see how we do this. Okay, so now let's see. First of all, maybe let us try to calculate the delta x is 1 minus 0 over 8. So which is 1 over 8. Okay. Then in this case, so we are going to separate this into 8 interval, right? Okay. So I will have 1 8, 1 4, 3 8, 1 half, 5 8, 3 4, 7 8, and 1. Okay. Okay, so after we have this, then we could plug it into the trapezoidal. T sub 8 is 1 8 over 2 f of 0 plus 2 times f of 1 8 plus 2 times f of 1 4 plus 2 times f of 3 8 plus 2 times f of 1 half plus 2 times f of 5 8, 2 times f of 3 4 plus 2 times f of 7 8, and remember the last one is just f of 1. Right? And of course, in this case, my f functions is cosine of x squared. Okay. Then to this one, we could use a calculator to help us to evaluate this. So we found out that the number is 14.4373255, and divided by 16 is 0.9023328. Okay, so then how about m sub n sub 8? Okay, so again, it will be 1 8. Now remember to this one right here, then the number that we are using is the midpoint, right? So therefore, the midpoint of between 0 and 180 is 116, 316, 516, 716, 916, 1116, 1316, and 1516. Then, okay. So n will be f of 116 plus f of 316 plus f of 516 okay. Then again, if you use your calculator, you will find out that the answer that you have is actually 0.905620. Okay. Okay, so the Simpson rule is S sub 8. It will be 1/3 times delta x multiplied to, again, is the y naught f of 0 plus 4 f of 1/8 plus 2 f of 1/4 plus 4 f of 3/8 plus 2 f of 1/2 plus 4 f of 5/8 plus 2 f of 3/4 plus 4 f of 7/8 and plus f of 1. Okay. Again, the pattern is 1, 4, 2, 4, 2, 4, 2, 4, 1. So therefore, again, remember for the Simpson rule, then the n must be even. Then now, use a calculator to see what we have now. Okay, so the answer from the calculator is 0.904524. Maybe just use 6 decimal places then. Okay. So that's it. So this is how we work with the approximations. And right now, I would like to talk about how do we actually work with the error band. Okay. Now remember, to the error band, for the in this case, we work with the trapezoidal, right? So then to this one, let us work with the error of t sub n is less than or equal to k sub 2 b minus a to the power of 3 over 12 n squared. Okay. Oh, by the way, this one should be 8. Because our n is 8, right? Oh, typo. Okay. And now let's see how do we actually find k sub 2 now. So remember, how do we find k sub 2 is the maximum value of the f double prime of x, right? So we need to work with the second derivative now. So we have f of x is equal to cosine of x squared. Then f prime of x is actually, it will be negative 2x sine of x squared, chain rule, right? And then f prime of x is negative 2 times, okay, the derivative of x is 1, so I have sine of x squared plus x times the derivative of sine of x squared, which is cosine of x squared times 2x. And now I will have negative 2 sine of x squared minus 4 x squared cosine of x squared. Okay, so now how do we actually find the maximum of this? Now, of course, if you remember in Cal 1, then how do we find the maximum value of the functions? Okay, it's actually, we could use the first derivative test, right? And then find the equivalent numbers, and then work it out the equivalent numbers, and then find the local maximum or the absolute maximum this way. Okay, so the technique is really good to work with polynomial functions. Okay, however, when we work with the trig functions, okay, there's one thing that you have to remember. Okay, this is something that you should know. Is if we have a psi of x, okay, now remember to the psi functions, basically is bounded between -1 and 1. Okay. So what does this mean? It means that psi of any functions, okay, because again, the magnitude in this case right here is always bounded between -1 and 1, okay, the output of it. So therefore, sometimes we could say that is the absolute value of psi of any functions this must be less than or equal to 1. Okay, same thing with the cosine. Okay, so therefore, again, when we if the function f that we have is related to the trig functions, then actually this way is easier to work with. If the f function is polynomial functions, then basically we could take the derivative of the second derivative, and then from there we try to locate the local maximum or the minimum. Actually, we just need to locate the local maximum then. Okay, yeah, this is the idea. Okay, so now let's see how do we actually analyze this one right here to find the case of 2. First, we know that for x is between 0 and 1, because again, do you see that the upper and the lower limit is from 0, the lower limit is 0, right? The upper limit is 1. So therefore, x is between 0 and 1. Psi functions and cosine functions, they both positive. Okay. So therefore, in this case right here, if we want to find the absolute value of f double prime of x, then in this case, we are going to take the absolute value of -2 sine of x squared minus 4 times x squared cosine of x squared. Okay. And then in this case right here, we could take out the negative sign. Okay. And then we know that the absolute value of a negative basically is just a positive, right? Okay. Let us continue. And also sin psi of x squared is less than or equal to 1. Cosine of x squared is less than or equal to 1. And again, x squared is less than or equal to 1 because again, remember x is between 0 and 1, right? And of course, for x is 0, 0, 1, okay? Then now we could actually work with this one. Must be less than or equal to 2 times 1 plus 4 times 1 times 1. Then this is equal to 6. Therefore, in this case, we find out that case of 2 must be 6 then. Okay, so once we find out that what is case of 2, then we could actually evaluate the error band. So I have the error of t sub 8 is less than or equal to 6 times b is 1, a is 0 to the power 3 over 12 times n is 8, right? So therefore, this is actually is the error band for the at the maximum error band for the t sub 8. Okay, so now then let us look at the next example now. We would like to use the error band to find a values of n for which e sub t is less than or equal to 10 to the power negative 4. Okay, so what we are looking for is we are looking for the error of t sub 8. Okay, is less than or equal to k sub 2 b minus a to the 3 over 12 t sub n. Okay, n squared is less than or equal to 10 to the negative 4. So right now we would like to find the n. Okay, so then now for k is equal to 6, and b is 1, basically we just need to try to solve for n in this case right here. So I will have So I will have 1 over 2n squared is less than or equal to 1 over 10 to the fourth. And then we have 2n squared must be greater than or equal to 10 to the fourth, right? We take the reciprocal. So I will have n squared is greater than or equal to 10 to the fourth over 2. Okay, so then this one right here is about 70.71. So then in this case, we could make n is greater than or equal to 71. Therefore, taking n equal to 71, we answer that the desired accuracy. Okay. So now, maybe let's pause the video and then try to see if you could finish the next example. Okay. Okay, so let us take care of this problem now. Okay. So to this one, we would like to work with n is equal to 6. A is 0, B is 2. And now we could have delta x is 2 minus 0 over 6, which is 1 over 3. And between 0 and 2, then we separate this into 6 intervals, right? So this is 1, I have 1/3, 2/3, 4/3, 5/3. Okay, 5 over 3. Okay. And then now to the trapezoidal, then I will have 1/2 times delta x multiplied to f naught plus 2 times f of 1/3 plus 2 times f of 2/3 plus 2 times f of 1 plus 2 times f of 4/3 plus 2 times f of 5 over 3 plus f of 2. And again, if you use your calculator, plug it into the functions where f of x equal to x to the third, okay? Then you will get 4.1111. Okay, now the next problem is t sub 6 is too large or too small? That means they would like to ask the approximations, okay? If the approximation is too large compared to the actual values or too small, then in this case, first of all, you will see that to x to the power 3, between 0 and 2, okay? Then maybe let us try to draw a couple trapezoidal. Maybe just 2 of them then. You will see that in this case right here, basically we see it right away that the approximation, the t sub 6 is actually too large compared to the actual area, right? Since x to the power 3 is increasing, is an increasing and concave function between 0 and 2. Okay. Okay, then now let's see how do we find the k values now. Okay, we would like to show that k equal to f double prime of 2 may be used in error band and find the error band. Okay, now then remember, how do we find k is we need to find the second derivative, right? Okay, so now you will see that the f double prime of x is actually 6x. Now the function of 6x is actually the slope is positive, meaning the function is increasing. So we could actually write it like this: since f double prime is an increasing function, in between on the interval 0, 2, right? Then is maximum value occur at x equal to 2. We may take case of 2 is equal to f double prime of 2, which is x times 2, which is equal to 12. So we could actually find out that k sub 2 is actually 12 then. Then we work with the error of t sub 6. So 2 minus 0 to the 3 over 12 square. Two over 9, or about approximately is 0.2222. Okay, so now let's check out. First, we are going to evaluate the I and check the actual error is less than the band compute in B. Okay, so then let's see what is I as we integrate between 0 and 2 to power 3 dx. Then we know that x to the power 4 over 4 integrate between 0 and 2. Then I have 16 over 4 minus 0. So I have 4. Okay. Now remember, this is the actual values, the exact value. Yes. Okay. And then now we would like to calculate the error. Okay. Now remember, the error is the difference between the actual values, the exact value 4 and the approximation, right? So which is 0.1111. Since 0.1111 is less than 0.2222. Mutual error is indeed less than the maximum possible error. Okay, so then that is it. Okay, for this lecture right here. Okay, again, in this lecture, I introduce the two more approximation, right? The trapezoidal approximations and the Simpson rule. Okay, and I also mention how do we actually work with the error bands. Okay, so again, work on the homework. If you have any questions, email me or join my office. Okay, thank you.